Okay.
Hi, everyone. Okay, so today we're going to be doing the live solve of the USACO 2022 December bronze. This is our first ever live solve, and it's really important or really interesting to see the way that someone thinks about the questions when they actually solve them. So that's why today we're going to be welcoming two members from CPI, and I'll let them introduce themselves here.
Yeah, hi everyone. I am Evan, and I'm one of the presenters, and I'll be solving the three problems alongside Ryan.
Yeah. Hi. I'm just gonna be here. Okay. Do you want to get started?
Yeah, sure. So I've already got the problem pulled up right here. I took a peek, I saw the picture, but I didn't really see anything else. So yeah, let's just get started then. First of all, I just want to comment that we don't see that many illustrations in problems just for the sake of, art, but yeah. Okay, so Farmer John is hoping, should we read the problems out loud, or do you think, we can read?
The problem seems
Yeah,
pretty short, so sure, why not?
yeah, perhaps we can summarize it afterwards, but yeah.
Yeah. Okay, so Phone John is trying to open a new university for cows, and there are N cows who could possibly attend his university. Each cow is willing to pay a maximum tuition of CI, and then he can set a tuition to whatever he wants, and it looks like all cows must pay to enroll. If this tuition is greater than the maximum a cow is willing to pay, then the cow will not attend. Farmer John wants to make the most possible money so he can pay his instructors a fair wage. Please determine how much money he can make and how much tuition he should charge. Okay. First line contains N, and then we have the CIOA. And output the maximum amount of money that he can make and the tuition that he could charge.
Okay.
Okay.
So first of all, I feel like, of course, every time when we look at the problem, the most important thing is look at the constraints, right? It tells you immediately what algorithms that you can and cannot use. So, for example, if the constraints were small enough, and in the subtasks they are, you could just go through every possible tuition and then see how much money you will make, and then just return the maximum. But in this case, of course, it's not possible unless if we're just trying to do the subtasks. So yeah, I think actually I'll briefly describe the subtask for what I mean, for going through all the possible tuitions, and from there determining what the maximum amount of money he can make. So in the first subtask, we see that CI is almost 1,000. And I'm assuming that, I'm sorry. Whoops, I think I misread. No. Okay, no. Yeah, but if both CI and N were, if you multiply them together and they're like at most 2.8, then it is possible to go through every tuition and go through every cow. But yeah, just looking at this subtask, I'm not sure what they're trying to make us do right now. Give me a minute to think.
I think it's like
Okay.
we want to go do all possible tuition values, but like
Yeah.
iterating to the cows is like still my time limit exceed. Wait, 1,000 times 10 to the fifth. What is that?
Do you want to explain to the viewers why you're calculating the multiplication of C and N and like what the upper limit is?
Yeah. So that's a good question. For those viewers who are not too familiar with time complexity yet, in competitive programming, usually you have this big O notation, where you write the time complexity, or the roughly how many operations you would do within these brackets right here, and you write the O right here. So for example, if you're going to do, just as an example, 2 times n times m, right? You write n times m right here. You remove all the coefficients in front of them. And usually you can use this. Well, I usually use this to evaluate how many operations you will do after removing the constant factor, which is in this case a 2. And then usually if it's at most 1E8 or 2E8, then you can probably then the solution, your program will likely pass under the time limit of 1 to 2 seconds. But of course, this constant factor is not, you cannot ignore it all the time. So yeah, that's why we're doing the multiplication and seeing if it's under 2E8, 1E8. So I do have an idea. However, the idea solves the entire problem, which defeats the purpose of trying to look at the subtasks. So what do you think, Ryan? Do you have any ideas for solving the subtasks only, but not the entire problem?
That's cool. I think I had a solution to the entire problem as well. But I think for the test case 2 to 4, it looks like 1,000 times n. It's like 1E5. This is like.
Whoops! I misread n. I thought this was 6 for a second. Yeah, I guess.
Oh.
Yeah.
Yes.
Then I guess
so it's only 1E8.
Yeah. I guess then we can do that. So basically, yeah, we can just loop through all the possible tuitions from 1 to maximum tuition 1,000, and go through all the cows.
Okay, maybe you guys can just skip to the full, or start and explain what you think is the full solution.
Yeah, sure. What I think the full solution could be is we have this thing called a frequency array. Okay, I like writing pseudocode when I think, but I'll explain what I mean. I'll try to do my best. But if there are any questions, Melody, you can let me know and I'll answer them. So we can store a frequency array. So so I'm writing in C++. It's more like pseudocode plus C++, but yeah. So first of all, we declare an array called freq, which stands for frequency. And in here we write C, which is the maximum possible tuition, which in this case is 1E6, 10 to the power 1 million. And of course, we denote frequency, let's say x equals how many cows can pay at most x, right? Let me just make sure that's, yeah. So in other words, how many cows can pay x or less? How many cows can pay exactly x, right? So how many cows I can satisfies CI is equal to x. And then what we will do, of course, we want to for each x I'll just write in C++ before. Right, so we're now going to loop through every possible tuitions from 1, the lowest possible tuition, to the maximum, which is C-1. And here we want to somehow find the sum of all tuitions at or above x. And we're going to use a frequency array to help us with that. So the sum of all tuitions at or above x, that is equal to frequency x times times x, right? Because there are frequency x cows who can pay exactly x, and each one of them contributes x, plus frequency x plus 1 times x plus 1, again, because there are frequency x plus 1 cows who can contribute x plus 1 each. plus frequency x plus 2 times x plus 2, and so on, all the way until frequency c minus 1 times, c minus 1. That's my thought process so far. I can explain further, but what do you think, Ryan? Do you think, did I make a mistake somewhere here? I might be wrong somewhere and I didn't notice.
I think it's just pretty good, but is it time, like how you planning to calculate like this frequency x plus frequency x plus 1? Because that might be a little bit.
Yeah, exactly. So so the way, why can I not? That's really, okay, sorry about that. The way I plan to do that actually is to loop backwards. So we're going to keep a variable called cur. Let's do long cur equals 0. And this will keep track of, this value right here. And we update it for each iteration. So let me just. So like I said, we loop backwards from c minus 1 to 1. And we update cur, and we let answer equals max answer and cur. So what is answer right here? Well, answer here is the answer, right? Initially it's 0, but we go through each tuition price, which is X, and then see how much money we can make for each iteration. So to update cur, let me see. So wait, sorry, let me just reread part of the problem statement because I think I might have made a mistake. Oh shoot, sorry. No. We do not, no, sorry. This equation right here is wrong. Okay, let me just readjust. So instead of frequency x times x and the frequency x plus 1 times x plus 1, the sum of all tuitions at or above x is this value, which is how many cows can pay the tuition, right? So because if your money is at least x, then you can pay the tuition. This is how many cows that can pay, and for each of them they pay x, right? So really, current is the suffix array of frequency. I think sorry, I fixed my mistake. I think that's probably the solution. Let me just
Oh wait, I thought that like the cows would always pay the maximum. Do you just pay like the smallest amount?
let me read.
Oh yeah, I think they do, because all 3 cows pay for an example. So I guess they only pay. Yeah,
I think. Wait,
okay.
give me a sec. I think they only pay the tuition, right? I mean, intuitively, they probably wouldn't pay more than the tuition. Wait, let me just make sure.
Yeah, I think they only pay exactly to the tuition.
Yeah. Okay. Cool. And then to update cur, sorry, let me just make sure I update what I make it clear what cur is. Current is basically keeps track of this value right here. In other words, it's a suffix sum of frequency, right? Or we could create a suffix array, but that's closely related to prefix sum array, which is more like a silver topic. So I'm not going to really talk about that. So in order to update cur, we just add frequency x to cur, right? And you can validate that cur will always represent this value right here, because before you update this, we can assume that current is equal to frequency x plus 1, frequency plus frequency x plus 2, plus all the way up to frequency c minus 1. And after this line, frequency plus equals cur plus equals frequency x, then is updated to this value on the left side. Yeah, and then we update answer with itself. Sorry, we update answer to equal to maximum between itself and current times x, right? So I think that's the basic solution, the pseudocode for the solution. Yeah. And that should be the full solution because we can loop through C. We can loop through from C minus 1 to 1, right? Okay. Yeah. Oh yeah, and Ryan, do you mind helping explain the time complexity of this solution?
Yeah. So I think frequency X is actually I think I can improve this a little bit because we only had to iterate through the specific values of CI because we can actually skip any intermediate values. Because if you have like a cow which pays X, oh wait, we have a cow which pays X, and then we have a cow which pays Y, then it doesn't really help to like set a tuition to some value in between, because then we can just snap it to like either Y or either X, and then it wouldn't change the solution. So
Yeah.
if we
and we're
change it to
assuming,
like,
sorry,
yeah.
and we're assuming there are no cows, no cows willing to pay tuition between X and Y, right?
Yeah.
Okay.
And then I think it just changes to like a map or something, and then we could just like do the same thing. And so this could be what this C minus 1 to 1. So this could be either max CI, or it could be just N. So depending on how you implement it, I think you could do both time complexities, because CI is only like 10 to the 6, right? Yeah.
Yeah, that makes sense. Yes. Yeah, and both O of N and O of maximum CI or 1e6 both will pass. So yeah, we can do that. And just another like super minor optimization using what I can't sorry, give me a sec. I can't edit for some reasons. But anyways, we could like continue if frequency X is equal to 0. I mean, that's just like a super minor optimization, but yeah, sure. We could do both ways, but in my opinion, if we just loop from the maximum, if we loop from C, capital C, which is the maximum possible value C minus 1 to 1, it's a little bit easier because we don't have to like keep track of the maximum value of CI. So yeah, I guess both ways are fine. Would you like to implement this, or do you want me to like do it this time?
I think how about for this one you type it up, because
Sure. Okay, I'm just gonna flip my window. The input description first contains N and then the values C. Okay. So I'm going to declare these variables as global because that's a good habit to do in competitive programming only. And then we're going to create a frequency array, and it's going to contain C values, where C is the maximum possible value of C, which is 1e6. And we're going to have 5 to that because it's when we do something like this constant C or constant anything equals something, we can add a few numbers to it, and it won't really change. It will very likely not make us exceed the memory limit if we didn't already. And also it helps us in the case we're doing like one indexing.
Wait, really quickly, could we make the code a little bit bigger?
Oh yeah, sorry about that. Okay, I hope that's clearer now. Yeah, and we're now going to take in the input, and yeah, and in this case we could do like a for loop, or we can just do something like this. So the while n minus minus, it basically loops the body right here n times, and right here this for loop also runs the body n times. So it's really equivalent, but this really changes n to be 0 or sorry, -1 afterwards. So it depends on whether we need to use n afterwards, but in this case we don't. So we can just use this. It's shorter to type. So yeah, in C, we're going to take an input and the frequency C++. Yeah, I'm not gonna. And here we're going to define answer, and also we're going to define a which it can be 0. Yeah, so actually it could be easier to define it as, no, it's fine. And right here, I'm just basically writing the pseudocode, but in proper C++. Yeah, so current plus equals frequency x, and answer equals max answer. Long, or we can do 1 long times curve times x, right? Because curve times x could be bigger than maximum value of that an int can hold. So yeah, in the end, we just print answer. I think if I remember, okay, let me just test on the samples quickly. That's weird. It seems like I cannot click the input. Brian, do you mind helping me?
Yeah,
Oh, it's right.
I can run it. It outputs 12, which is correct. But we also have to print out the
right. Yeah, I neglected that part. Right. So then that's another pretty common thing that we might have to do. So yeah, do you want to do this, or do you want me to explain this too?
How about you explain it first and I can implement it?
Okay, that's fair. So in this case, whoops, I'll write it right here. So in this case, we're gonna have to keep track of the most optimal tuition. So I still cannot edit, which is really weird. I'll remove. Yeah, okay. Okay, now I can edit. Sorry about that. We can keep track of the optimal tuition. So TUI, that's the optimal tuition. And whenever the answer is updated to something higher, we also update to optimal tuition. And we know that it won't, I'm setting it as 0. We could set it as anything else, but we know that answer is going to be updated sometime in the future, so that we also know that tuition is going to be also updated. So yeah, right here, like I said, when we want to update answer, if current times x is bigger than answer, if we want to update answer, and also we want to update tuition to be x in this case. Let me just yeah, and we can remove that. And in the end, we have our answer and we have the tuition. So yeah, that's taken care of. All right, Ryan, it's your turn to implement it.
Yeah, so let's stick with the TUI, yeah?
Sure.
And then we're going to initialize it to some really large value because we should be, actually, it shouldn't really matter since we're iterating backwards anyway.
Yeah, it doesn't matter if we like don't like initialize it at all. So
okay, so our current candidate is going to be this value from earlier, and if this candidate is greater than equal to ans, because if we ever have the solution where we get the same profit, then we should always take the lowest one.
oh, sorry,
then,
I missed that.
Oh, yeah. And then if it's greater than equal to ans, we'll set ans equals candidate, and we'll set a TI to x. And then we can remove this, and then we'll print TI as well. And then, can you run it, or?
I mean, wait, is this linked to the problem? No, I cannot click
Okay.
the input, so unfortunately, no.
Could you like try to click the divider between input and like std out? That one, yeah. Oh, okay.
Interesting. Yeah, so 12.4, that is correct. Okay. Yeah, I'll download this file and I'll submit it. Nope. Okay.
Nice.
Oh, we have a quick question, I think. It says, what's the purpose of candidate?
Candidate isn't really needed here, but it kind of makes it easy to read. So candidate is like our current, here, I'll add a comment. So candidate is our current to a current profit if we choose X. And then so since we're using candidate twice here, I thought I might just make it a named variable instead of having to type like it twice. But it's basically the same thing. I just added an extra variable. Did it
Yeah.
pass? Okay.
Yeah, I did pass it. All right. Do we have any more questions from the chat?
I think that's good. Let's move on to question 2.
Okay.
Okay, maybe this time you guys can read the question silently and then kind of summarize what you think it means.
Yeah, I agree. Okay.
So
Yeah.
I think the problem
Also,
means
yeah.
yeah, you go
Go
first.
ahead. Okay. Yeah. So the problem basically has, we can imagine it as I'll draw it out. We can basically imagine an array of n elements. That's not a good drawing. Okay. N elements, and each element in the array is either a G or an H. And here we want to, so here we have a second array, which is the same size. And each cell in the array can be either empty or G or an H, for example. So basically what these two arrays represent is, the first one represents the types of cows, and the second one represents the grass patches. Yeah, and each cow will go to the nearest, each G or each H will go to the nearest position in the second array, the grass patches, that has the same letter as themselves. So here, this H will want to go to here, and this G will want to go to here, this G will want to go to here, and so on. If there are several, oops, okay, sorry about that. Yeah, let me undo. Yeah, if there are, if a cow needs to move more than k steps to reach a grass type of their type, so if this G needs 1, 2, 3, 4, 5, 6 steps to reach here, if it's at most k, then that cow is fine. So yeah, they basically, each cow has a range of motion, like a range of positions that they can be to eat a patch of grass. And if a patch of grass of their type is not within that range, then the cow cannot eat grass. The problem asks us to construct any array of the second array with the minimum number of grass patches, so non-empty cells. Yeah, okay. Sorry, give me a sec. Let me take a look at the constraints first of all. Okay, 1e5. So we probably have to use like a linear algorithm to solve this. Yeah, Ryan, what ideas do you have?
I haven't thought of a solution yet, but I think it might help to like write out the rule as just like a solid if statement. So like if we say like X is the closest grass type or grass patch of that type.
Sorry, do you mean X is the distance or
No.
position?
I'll write it in later.
Okay.
And then if we're currently on cow I, then the absolute value or between I and X should be less than equal to K for all I. And that's just like a very English way of finding this problem.
Yeah, yeah. And what makes this a little bit difficult, in my opinion, is that you cannot place two of the same, you cannot place a G and an H on the same position. At least that's what, let me confirm that. Okay, yeah, he cannot plant both at the same location. So that's what makes it a little bit difficult. Okay, yeah, this equation, yeah, I agree with this equation. Straight away, I'm going for the full solution instead of looking at the subtasks. I mean, we could do the subtasks, but I think it's a little bit, I mean, I'm not sure if we have like enough time to do that. So let's just consider the full solution for now. Okay. I'm very tempted to use like binary search, but then this is Ron's problem.
Yeah. I'm thinking of like sort of like just one linear sweep through it with just like a bunch of casework. That seems really annoying to write.
Okay, so perhaps, yeah, maybe we can write like a short generator to generate like cases for us to work with, because that's what I usually like to do in times like this. So I'll just like clear this actually. I mean, do you think we should clear this?
I can write it in Python if you want.
That works.
And so
yeah.
Okay. So we have just like, what is that? N equals to like 5.
Between 1 and 1e5.
Is 5 too big?
Usually I like to like randomly generate n and k. Or it doesn't really matter.
Yeah, we can do k as well. Okay. So let's say like n is between Oh my God, what am I writing? Between like 1 and 5? Or say K is between, what's K between?
0 and n minus 1.
Okay. And then for range N, we'll say choice equals rand int 0 to 1. If choice equals 0, then we'll print H. Otherwise, we'll print G.
Yeah, and we just want to make sure to print n and k too.
Yeah, yeah. And then hopefully that should generate. Okay.
Perhaps we can
Maybe we
make
should
this a
make
little bit
this
bigger.
bigger. Yeah.
Okay,
Like
Vim
10.
is not working. Oh, sorry, give me a second.
Yeah.
Okay, I feel like this is good enough.
Yeah.
I'll just copy into the right here, and that's okay. I don't know what if there's a way for us to make this bigger. Whatever, that's fine. Yeah, so first of all, what I observe is we need to have, no, that's fine. This H, we need to have an H somewhere between here. And for this G, we need to have a G somewhere within this range. So to have a G here.
Or you could also go backwards for that one as well. But I'm pretty sure it's not optimal. You can also extend it here if you really wanted to. Because it's
Sorry.
doing both directions.
Sorry, I'm not sure. I'm not following.
Oh, because like this G, the closest grass patch could also be behind it. So this range could also.
Yeah. Good point. Yeah. Okay. It's just really the we cannot put two grass patches on the same spot. That makes this difficult. Otherwise, we can kind of use greedy.
So if that's the part that makes it difficult, what if we just tried to solve the question without it?
I mean, okay, so if this is just the case, we won't consider the G. Yeah, good point. We should probably do this first. So we can put an H right here because it's optimal to put it here. I mean, because if you put it here, you will still satisfy the first two counts. Basically, we're trying to allow the counts to reach the grass patches from the left to right, if that makes sense. So basically, this is the rightmost position that we can have, that we can put an H at, so that we can satisfy this, and also that this satisfies this, and we just now need to consider from here to the end. So basically, we can put an H basically anywhere here. So that will be 2. Yeah. Okay, let me see what about the G case? So we can consider from here to here. And yeah, that basically solves everything. And these two don't overlap. So that does solve the problem, but we did get lucky. No, wait.
I think there's a case that exists where you have like, wait.
Are you
That
sure
might
there
not
is?
happen.
Yeah. So
because
wait, okay,
everything's
okay.
K.
Okay, this problem is
Uh, hmm. Well, if we had like two opposite things, like go into here, then we could just like squeeze it to like one to the left or one to the right, and it wouldn't change because that's like the only case. But if we always
yeah.
just move forward,
I have
then
this, I have this intuition. I'm sort of confident that I'm not completely confident though, that it actually won't intersect. And I might be wrong, in which case that's sad. But usually sometimes what I would do, since this is like a 4-hour contest, I would like just write a stress tester that will go through that would generate a bunch of different N's and K's and H's and G's, and then see if we solve it for independently for H and G, whether the grass patches would like intersect, if you know what I mean, whether there will be an H and a G at the same place. So basically like stress test our solution on a lot of different cases. And then after a lot of cases, if just solving independently for both G and H works, then I'll trust in myself and then just submit the solution.
yeah.
But in contests, usually if I don't have to prove it, if I'm quite confident that if you don't need to prove it, you don't need to, right, in contests. So what do you say? Do you think we should keep working on like a proof, or get a better intuition on why this is true, why we cannot have an H and G at the same position, or do you think we should start writing the solution?
I think it would make more sense to like continue the explanation. But if like this was me in a contest, I might just write up that solution and just submit it and see if it's wrong or not.
Yeah.
Mm.
Okay, for the sake of the viewer, I think I might have a proof. So let's say first of all, let's just call these two arrays let's just call, give me a sec. Let's just call the highlighted array array 1 and the answer array 2, right? Okay, just so that I don't have to keep calling them longer names. So array 1, we know that okay. I have like this intuition in my head, like kind of like a illustration, but it's hard to explain. Basically, let's solve for H independently in this case. And for example, we will get if K is equal to 3, then we will put an H right here. Right. And yeah, and we will continue solving. If we were just solving for independently for H, we will continue from here, right? And if we were to solve independently from for G, then we will put the G right here. So they will never intersect the first G and the first H, right? Because the first position of H and the first position of G is different. So first position of H plus 3 right here, compared to first position of G plus 3 right here are always different, right? Yeah, and afterwards, after we put the first H and G in their positions, in this case, the H and G's are here, then we can mark off the H's and G's that are the cows that are close enough to a grass patch of their type, right? And we will continue solving for the next, starting from, if we were to solve independently for H, we would start from the next unsatisfied cow, meaning a cow that's too far away from his or her type grass patch. And in this case, it's right here for H. And G, that's right here, which is different from the next starting point of H. I hope I'm making sense. Yeah, by the way, it's okay. Yeah, I hope if any viewer is confused, I hope they ask questions. And I'm pretty sure that they are different because
I I think if you have to go back from like this G at the end, then I think you just have to like squeeze it into something over here because that's like the only case it's gonna happen. If you have like an endpoint and then and you have to go backwards, then you might just squeeze it somewhere in here.
Okay, you mean like if we have to, sorry, do you mean if we have to place an H and a G at the same position?
Yeah. Or like
Okay.
if this G is satisfied and this G is not, then we have to like, oops, then we might have to do some casework and just be like, oh, we can't place it at something like over here. And so we'll just place it here somewhere. Because an H might satisfy that spot.
Okay. Sorry. I'm still thinking about my proof right here. And wait, sorry, let me just continue with my proof right here. Yeah, what I'm saying is the first positions of H and G's, if that makes sense, the first unsatisfied H, Holstein and Guernsey are always different. So whenever we place, okay, I hope I'm making sense right here. So what I mean by unsatisfied cal is a cal that is not close enough to a grass patch of their type. And the leftmost unsatisfied H and the first leftmost unsatisfied G will always be different. So when we place the next grass patch of type H and G, they will be at different positions because we will always add K to. So for example, like I said, here's the first unsatisfied H. Here's the first position of the unsatisfied G. When we place the first H patch, we will always place it K positions afterwards, and so that the H and G will be different. But then at the very end of the array, say if we have the array like this, right? And this is the first leftmost unsatisfied H and leftmost unsatisfied G. We might place these together. Okay. Yeah, never mind. I guess my proof isn't correct like every time.
I'm pretty sure if that happens, we can just like squeeze it to the left or to the
like
right
what
a
you
little
said.
bit.
Like what you said. I just want to make sure that it's yeah, we can probably do that. But then if we squeeze it to the left, I'm just worried that there might be another H here. So and okay, so I think if no, there will not be another H right here, because if so, then this will not be the leftmost unsatisfied H cal. I hope that makes sense. Right, so yeah, I think you're correct. Only case
That
being,
strategy will work.
sorry, what's that?
I think I don't think that there's like a case where it'll intersect here. But like if we do place an H on this G, then we'll just place a G on this H. Or just place a G to like the left. So I think that'll always work.
Yeah, the only corner case is like K equals 0, I think. Wait, right? I think so. I think that's probably the only corner case where you can, if you squeeze like the G to the left, like one place there will be an H, or even two places there will be another H. Okay. I'm not absolutely certain that this will always work, but do you think we should give it a try?
Sure.
Okay.
Do you want to write the code?
Yeah. I usually like writing the pseudocode first, or like writing the basic structure of the program. Yeah. So we should probably solve for H and G independently, and then if there is a conflict where if there's an H and a G at the same position, then we move one of them.
Yeah,
to the
that
left.
makes sense.
Yeah. Okay. Cool. I guess what I would do is create like or like a vector of bool of solve, and then vector of bool how. Basically, what I would do is to create a function that solves independently each case. So this function solved takes in a vector of bool. So if so if cal I is true, then there is a cal at position I, and it returns a vector of bool where returns a variable called answer where answer I is equal to true if and only if there is a grass patch. So this is what I would do if I were to like solve independently. Yeah, and then just have two vector bools for each for H and G.
Yeah, that sounds good.
Okay. Yeah, do you want me to write a pseudocode so that it's like clear to the viewer, or do you think you can like help explain it while like writing the actual code?
Yeah, I can write some comments while you code. So
Okay, yeah, sure. Are you drawing on the whiteboard?
me? Not
Yeah.
right now.
Okay. Okay, yeah. I guess you're just thinking about the implementation part, right? Yeah. So let me just write like a bit more of a pseudocode, like more pseudocode. I would write, I will create a variable called last, which is equal to the last grass patch in the answer. So I need to get the indentation just right. So we'll create an answer count of the same size as cow, and last position of grass patch, and I will go through each element in cow, and then yeah, so and then I would see if this cow, first of all, if not cow I, if there's no cow at position I will continue, right? Because we don't need to worry about like an empty spot where there's no cow. But otherwise, we would see if I minus last is bigger than k, or bigger than or equal to k. No, bigger than k, meaning that if cow I cannot reach the previous patch, then we will put a patch at then we will put a patch at no, sorry. Yeah, we'll put a patch at minimum between I plus k and L dot size minus 1. I hope that makes sense. And also we will update between, no, sorry. Yeah, so for the viewers who are wondering what I'm doing here, so basically I'm using a greedy approach where I placed a grass patch to the rightmost position. Greedy. So I think a visualization would be better. Yeah. Ryan, do you mind working on this? Yeah, I guess you can work on the code while I explain it. So for example, if k in this case is equal to 3, then, and if the input to the function cal is equal to this, where a 1 represents a true value and 0 represents a false value, then the answer would first of all be, of course, we can see that this is the leftmost cal. Remember, we would go through, yeah, let me just keep explaining. I apologize if my explanation isn't great because I didn't prepare for this. The first answer will be here and then plus 3, so 1, 2, 3 right here, which would means that all these 4 cals would have a grass patch to go to. And then when we meet the next cal, that is not close enough to a grass patch, in which case this condition would be true. Absolute I minus 1 last is bigger than k. Then we would continue. We would do the same thing, right? So we would want to satisfy this cal, but we want to place it to the rightmost position such that it will satisfy this cal. So 1, 2, 3, we'll place the answer here. We will place the graphs right there. Yeah, and last will always be LA right here. Will always represent the rightmost position of a grass patch. And whenever we place a grass patch, we will make sure that the every cal to the left and at the rightmost grass patch is able to get to a grass patch. Yeah, so that's the basic intuition. Yeah, I in my opinion, it's intuitive enough for me to not prove, but yeah, I'll try to do a quick, like, simple proof, intuitive proof. So for example, so right here, when we're just starting out, we know that we have to place a grass patch to satisfy this cal to be close enough to the leftmost cal, which means that we have to place it within here. And there really is no reason to place it here, here, or here instead of here, right? Because if you place it here, you will satisfy all cals to the left of it and potentially satisfy more cals to the right of it, right? And after you place this grass patch, let's mark off all cals that are satisfied. And for the next cal, next leftmost cal, which is this cal, that is unsatisfied, we do the same thing. We could place it anywhere between here and here, right? We can place it here, 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 or here. But there really isn't any reason to not place it at the rightmost position, because if you do, you will satisfy all cals to the left and maybe more cals to the right. So that's the basic greedy solution. I hope that makes sense. Oh,
I feel like I'm forgetting something in this for loop. Do you think
Oh.
do you think that looks good?
Yeah, sure. Yeah. Okay. So you want to do absolute value here because last position can actually be bigger than I. Yeah.
Oh yeah. Not bad.
Yeah, if you look at
You're
this
right.
example, we place the first
Mhm.
one right here, which is bigger than, for example, this count.
Yes. And then I guess our actually let me just make this global. I don't wanna what should I name this?
Name what the G's, H's and G's.
Yeah. Is that okay? Like that's
Yeah.
really
Yeah, usually I would just if A and B are available, I would just name them A and B. But for the sake of readability, yeah, H's and G's are better. Yeah, for the next step, we would I think there will be at most one overlapping one position in which an H and G will both be true, and that is the last position I theorize. Well, first of all, sorry, let's just handle the corner case where k equals 0,
yes.
because that might mess things up. I think that's a corner case. H's and G. Okay, wait, what do we print if it's?
Yeah, this should be okay.
Oh, okay, yeah. Cool. All right, and then we just check whether the last question is the same, and if so,
I think let me just see if I can write out a case where it's not the last position because
in my intuition is there will be a position where the there will be an H grass and G grass only when yeah, I'll let you do that for now. Might be a little bit difficult to explain without taking quite a bit of time, actually.
Wait, what about this case? Because when you place the H here, then this view need to be placed here at this exclamation mark.
Wait, can you write the cows? What's the exclamation mark for?
Like in this case, we have like n equals 5, and we have this, and then we could just have like something. Well, actually, you might be right. If we place an H here, then we place in the answer, you could do like H here, but then G would also need to be here because this G is the leftmost, and then
Yeah,
we might have a conflict.
I think a way to like kind of prove why only the last positions of these two vectors of bools will be the same, will be both ones, is you see when you set answer last, or let me just look at the code. So when you set answer spot to true, if I plus k is not the minimum, sorry, if spot is equal to I plus k, then it will never intersect. So it will never intersect a, how do I explain this? Here, let me draw. For example, if k is equal to 3, then you will place a G, you will place an H right no, here. Yeah, if k is equal to 2, actually, then and if spot is equal to I plus k, which in this case it's right here, and for g it's right here, they would never overlap. So because they will never overlap, meaning like, yeah, I think you know what I mean by overlap. They will never overlap because I plus k for two arrays will always be different. So for example, if this is I and this is I plus k, and when we call solve again before g's, and this is I, then this will be I plus k for the case when we solve for g's. And these two values will never be the same because you would never have like an h and a g in array 1 at the same position. So that might be confusing, but basically I think yeah. Okay.
Is it guaranteed that like the second to last position one is gonna be clear? Because what we might just iterate from n minus 1 to n minus k minus 1 and see if anything's open.
It's probably going to be clear. That might I do have some intuition for why that's true, but yeah, I think what you've done here is good. Or actually, what I would do is I would just do assert false to like give us a random error. Yeah, I'll download this. Let me just check first. Ks and H.
We should print out the answer first as well.
Sorry, what's that?
We need to print out the answer for this.
Yeah. I would usually do like a string.
Oh, string. Yeah. Just do, and it's how you define a string, or is it char and then?
Yeah, it's just like a vector, how you would like put the number first and then put the char. They're pretty similar, strings and vectors. Oh yeah, I guess.
Ooh, I think
sure. Yeah, I was thinking of like appending to a string, but that works. It's fine.
Oh, yeah. At least that way we don't have to worry about adding in the periods. Yeah. Okay, let's see if that one's. Oh, we have a problem with the sample input. This thing is not working right. Yeah. Okay, that seems to be good.
Okay, I'll download this file. Hopefully it works.
Yeah, if it doesn't, that'd be very sad.
Give me a sec.
Okay. Thank God.
Yeah, I mean, I had some intuition why you cannot, if you swap the last I have
Yeah.
some intuition on why you if you yeah, like what I said previously, I think I have some intuition on why this always works.
Mm.
I'm not sure if we have enough time though to explain that.
Let's come back to it after we do problem 3, if we have
Sure.
time.
If there are enough people who want to know the
Yeah.
why I think that. Okay.
This problem's kind of confusing to read. Let me see.
I mean, I feel like it's not properly defined, but or never mind. Actually, no. I think it's no. I thought it was ambiguous. I don't think it's ambiguous actually.
Mm-hmm. This is. It seems like a very annoying problem to implement. N is 100. M is 100.
Okay, so yeah. Do you want to summarize the problem, or
Sure.
can I do it this time?
I can do it this time.
Okay.
What? Okay. I think the problem is basically asking, like, we have an array or just an integers, and we have to figure out where there's like a program such that in each this program is composed of like if else statements, and then each one will check the index of one of the array elements if it's equal to 1 or it's equal to 0, and then it might return 1 or 0. And when you check if there's a program that exists such that it gives the same output for all of these inputs.
Right, and the thing is, it doesn't necessarily check all positions, I believe. It at least doesn't say
It doesn't
so.
have to.
Yeah.
It just
Okay. I haven't done a lot of bronze lately, but bronze has definitely got a little bit harder. Okay. So yeah, again, I would like generate test cases, and I mean, it might be difficult too.
Yeah, how do you generate test cases here? I guess you could just generate programs and just test outputs, but that might take way too long to write the generator. Might not be worth it.
I'd rather, yeah, let's just look at the sample input then. It's
Yeah.
not too big, which is, yeah, purpose of sampling. I mean, sample inputs shouldn't be like very comprehensive. Okay, so if I guess, if two strings are completely the same and if their outputs are different, then yeah, it's lie. Okay.
Yes. For the last test case, we could just have 0, 0 and 1, 1, and that could already tell us the answer. Because the middle two don't really. Oh. Well, I guess the middle two together tell us something. Oh yeah, you need all four in the last one.
Okay, yeah. Yeah, I guess we said it is right. There's only one corner case. So what you said is if two strings are completely different and their outputs are the same, then that's a lie. The only
Wait, I don't think that's right. Because if you could just do like, oh, if b0 equals 0, we turn 0. Otherwise, we turn 0 anyway. I think that's a valid program. So that might not be right.
yeah. So the only corner case is if everything returns the same. At least that's what I think. Yeah. Yeah. If everything returns the same,
Yeah.
then it's not a lie. It's okay. But otherwise, if there are two strings that are like opposites, then yeah.
Mhm.
But okay.
Uh, well, like if we have an if statement, if we have like a theoretical if statement, then everything along that, which has like the same value, must return the same thing. So if we have like
we could like split.
if a0 equals 0, then we just check everything. Be like, oh, this must return the same thing.
Yeah.
Because the first if statement takes priority.
Yeah. Yeah, I've been thinking along the lines of that too. And only thing is, of course, we don't know which position is the first if statement. How the if statement looks like.
We could brute force it because it ends only up to 100, I think.
Okay, but then
Well,
we'll have to like see the second else if.
yes.
So that's like n factorial. So oh, I think this problem is basically trying to make us trying to discern all the string. I have a hypothesis. Perhaps we could, if the output is okay, we could have perhaps a chain of if else if / else statements that checks the first and then the second, and then so on until the last, or stops some way in the middle.
Yeah.
Because okay, let me see if it. Yeah, you can do it for this case because, for example, you can write if b0 is equal to 1, you return 1, and then you look at the second one. If b0 is equal to 0, return if b1 equals to 0, then you return 0, and then if b otherwise return 1.
Yeah.
Yeah, so basically my intuition is basically this problem wants us to like this. It's kind of like divide and conquer, where for each like assuming that if the chains of if and else if statements goes from left to right, which I mean I'm like only half sure, then it's kind of like a divide and conquer problem where you have to yeah. So first of all you split this into two like sets and you solve for each set independently. So first of all you split this into strings where the first position is 1, and you solve independently for the strings where the first position is 0. And then along, and then the second step on the recursion is you check the second positions of each string and then split it further. Because basically this problem wants you to discern the strings apart from each other, if that kind of makes sense. I hope that makes sense. Yeah, now think about that, it does make sense, but I mean, I don't have a proof right now. Yeah, it's mainly from my intuition where the problem wants you like to discern the strings from each other.
Yeah.
I don't know if that makes sense. And that's where the idea of divide and conquer came from. And where the idea of, it doesn't really matter if you check the first and the second, or yeah, I don't know how to prove that though. No. No, wait, no. No. No, my idea is not completely correct.
What if we propose like a theoretical if statement? Then that means everything along that line should have the same output. And then we know our program has to have at least like one if statement. So just propose an if statement, and then if it aligns with everything, then we can. Well, that doesn't really help.
Okay. I think I might have an idea. Okay, so you loop n times. For each time you loop, you wanna figure out one column, and apply an if/else if statement on that column, and then remove yeah, remove that column, and also remove all rows where the condition is satisfied. So what I mean is, for example, for each iteration, you might find that we can, for the second column, let's look at the second example. For the first iteration, the second column, we can see that for all of the strings that have 1 on the second column, their output is 1. So we can eliminate this, and this, and that serves as the first if statement. Again, this is just my intuition. I don't have any proofs yet. And then we remove the second column, second row, fourth row, and we're left with this, and we keep going. Of course, in the actual implementation, we would just mark it as removed instead of actually removing it. Would that work?
I think so.
The only thing we have to wait, shoot. Okay, yeah. Base case is if everything is the same, if everything, so yeah, meaning if every output is the same, then yeah, it's not a line. That's the base case of our recursion or iteration. Yeah, I'm probably not making sense right now. Okay. So the only thing we have to prove is the order in which we do in which we apply the if statements doesn't matter.
It makes sense that it wouldn't matter, but I want to do like a formal proof. Let's see.
So what I would say is for each iteration, whenever you remove a column and some rows, it doesn't matter in which order you remove them, because in the end you will remove all of them, no matter which way, in what order you remove them. Does that make sense? So when you apply an operation on the second column, you remove this row and this row. But if you apply an operation on, for example, here on the first column, you remove these two columns.
Yeah,
These
I
two
think
rows, sorry.
that, yeah, because like the output's consistent between like everything that you move, it shouldn't matter the order of your if else if statements.
Mhm.
Yeah,
And the
that
time
should be
limit,
okay.
and the time limit allows us to do that. So for each, we loop
Mhm.
n times or n times. Yeah, n times. Sorry, that's number of
Yeah.
columns. And for each of these iterations, we find a column where we can apply an if statement on, and then we apply the if statement, and then remove all columns / all rows that are that can be removed. That can be removed. And then
And
yeah. So
that would be n
that would
times
be
m times 2 times 2. So that's like,
okay.
yeah, that'll fit.
I'm like wondering, why is it so small though?
Yeah, I feel like
But
you
in,
could do like, it's like n cubed, right? If you had 100. Or
you can do
yeah.
n times m squared or n squared times m squared, which is
Mhm. So, I think,
no. Sorry, no. It is n times m, because for each n iterations, you will check each column, and to check each column, whether you can apply if statement on that column, you need m operations, right? To check whether
yeah,
you can apply. So it's n squared times m. So now
n
now
squared.
n squared times m.
Wait, how's it n squared again?
Yeah, sorry if my explanation isn't super clear. So we want to apply if statements at most n times. So we loop, we do the following n times, right? Because we in each iteration, we remove a column or declare that it's okay / alive. And then here
Oh yeah,
for I'm just gonna write I in range n Python pseudocode. I'll use J. Can column J be removed? Or can we apply if statement? Can we apply an if on column J? So can we apply an if statement on column J?
Yeah.
Right. And to check that, we will go through each. To check this, we go through each row, each m rows, each of the m rows. And see whether for all, yeah, does it kind of make sense why you need to go through m rows in order to check?
Yeah.
Okay.
Yeah, that makes sense.
Yeah, perhaps we can write the code and then explain why this works, why it checks whether we can remove.
And then wait, I think we can have like 2n if statements, right? Like, or 2n minus 1 if statements, worst case. Well, I think n times is enough actually.
Yeah, that would still fit the time limit.
I can start writing the code.
Wait, yeah, sorry, give me a sec. are you saying we could apply like an if statement or else if statement on a row or a column twice?
Yeah, because like you could say like if b1 equals 1, return 1. If b1 equals 1, return 0. Oh wait, no, that's so dumb.
That won't really do anything.
Yeah, that wouldn't really do anything. So it's the same as like not doing it at all. But your program would consider that, right? Because it'd be consistent throughout all the rows.
Okay. Yeah, actually, it could happen that we check the same column twice. So wait, but in that, okay, so but that doesn't really matter. Okay, so here, here's what I mean. So let's say these are strings. I'm just gonna write one column. So 0 0 0 1 1 1. Okay. Yeah. If we were to apply if the digit at column J is 1, we will return 1. And then afterwards we will, okay, sorry, let me think for a little bit. Yeah. In this example, we have to, if, for example, all the zeros map to 0 and all the ones map to 1, then we could apply like the same if statement twice on it. So if bj is equal to 0, return 0, right? Else if bj equals 1, we return 1, right? But for example, if not all the zeros map to 1, map to 0, then we won't apply the same if statement on it twice.
Yes.
Right. But if all the zeros map to 0, or if all of the zeros map to something and all the ones map to something also, then after this one operation, all of the output will be this. Sorry, yeah, all of the answers would be, all the output would be the same. Essentially removing these rows and all of the output will be the same. Does that kind of make sense? I hope I'm making sense to the viewers. Yeah, and in that case,
like theoretically, you could theoretically your program could go through 2 and if statements, but like
we don't have to do that. We just have to check if everything returns the same, in which case it will serve as the else statement.
Yeah, exactly.
So in this example, instead of putting else if bj equals, we just put else, right? I feel like there was a much better way to explain that. But whatever. Yeah, I think it's a little bit better for me to program this time. Just so that we and also I think some of the it's difficult to explain everything in my thought process. So it's better.
I will comment along your code.
Yeah. Okay. Let me see this. Okay, so test cases. So usually, yeah.
Oh my God. Yeah.
Okay, so we take an input, which is n and m. Usually I would like use n as number of rows and m as number of columns. So I'm just going to reverse that. And then these are the numbers. Okay. Let me just think about a little bit about the implementation. Vector of string. I'll call it A, which has n elements, and also vector of, I'll do string. I'll do bn, and these b doesn't actually correspond to the b in the problem statement. Actually, I'll do it that way. B, and then it's the output. I don't have a better way to put it. Yeah, the output is just one character. So
Yeah.
yeah. Okay, so we will also need a vector of bools. So whether it's the column, whether it's taken or no, not taken, sorry. Like if you haven't had an if statement considering the column, I'll just do taken. I don't have a better name for that. And also we need to have a vector bool for whether row is removed. Right. Yeah, okay. So we will repeat this n times. And we would actually probably not use that. And first, we would check whether every output, every row that is not removed has the same output, in which case we can basically effectively write an else and then return the same thing in our mini program that the problem statement said. So we will first check that. Okay. And we should also check at the same time whether all of the ones in this column has an output of 1, whether all the ones maps to a 1, and whether all of the zeros maps to a 0 or maps to the same thing. Okay. So let me just think of a clean way to do that.
I think you could do like a for I in M, and then for J in 2, and then for K in 2. And so it'd be like a column, if statement, and an output. Does that make sense?
Okay. Let me just look at it again just to make sure
You also need
okay.
you also need an after this.
Oops. We are. Yeah, sorry. We go through all of the columns. Yeah, you're right. Sorry. And yeah, okay. Okay, let me just yeah, I think I get what you mean. I think I have another way to do this, however. This might be a little bit difficult to comprehend, though. Oh shoot, we got to take in the input first. No. If Bij is equal to 0, and A0 is equal to -1, then A0 is equal to for I. We do it. Cool. Okay. I'll explain what I'm doing here afterwards. It's probably not the cleanest way to to implement this. Oh. Okay, so I hope this is correct. So basically what I'm doing is, yeah, so let me explain what all these for loops mean. So this basically is repeating the body m times, of course. We're doing that in m times again because we're going to go through for each iteration of this, we're going to try to remove one column, or otherwise in the program, and say whether it's a lie or okay. And here we're going to go through each columns to see whether we can remove, or sorry, apply an if statement on this column, on column J. And right here, A0 is equal to the output for A0, right? And also consistent 0 is equal to whether all zeros map to the same thing, right? Yeah, and A0 is equal to what does all of the zeros map to, right? If it's consistent, if it consistently maps to the same thing. And the same for 1. So if consistent 1 is true, then all ones map to the same thing. Yeah, and right here we go through all of the rows, and if the cell at row I, column J, is equal to 0, and also, oh, by the way, I put -1 here because we don't know what they map to yet. So -1 means that we haven't found any. So A0 is equal to -1 because it indicates that 0 hasn't mapped to anything yet. We haven't found a 0 in our search so far. Yeah. Whoops, give me a second. Give me a second. Sorry, that was my dad calling me to eat. Yeah, where was I? So yeah, we set it as -1 because it will indicate that we haven't found a 0. We haven't encountered a 0 in our loop right here so far. Yeah, so for each cell in this column, if the output for all zeros we've not encountered a 0, or if the output for all zeros so far is consistent with the output of the current row. I feel like this is pretty hard to understand for some viewers, but then we set the output for all zeros, right, to be equal to the output for the current row. Otherwise, if we have encountered a 0 before and its output is different from our current, let me just draw this out. It's different from our current output, right? These two outputs are different. Then we write consistent 0 is equal to false. And by the way, okay, this does the same thing as basically this. However, it's just for the case where the digit right here is 1. Whoops, is 1 instead of 0. There are cleaner ways to do this, but just for the sake of understandability, I'm not going to do that. Okay. No, so for
now it's just like row removed. if
Sorry,
it's
what's that?
consistent. And now we just had to handle like eliminating the rows if it's
Yeah. And first of all, we should, oh yeah, by the way, we should not, if column taken, okay, then we continue, right? Yeah, all right, cool. Oops, and of course, column taken here is here because we don't want to like apply an if statement to the same column twice. We could theoretically, but that's not necessary.
Oh, and
Yeah.
also if the row is, if we already eliminate the row, then we also don't have to go do it again.
That's
Right?
good. That's a good point. Yeah. Yeah. And right here, we just, first of all, we want to see if all of the output are the same. If so, then effectively in our mini program in the problem statement right here, we're basically writing else and then returning 0 or 1, right? So if no, we don't have to do that, but so wait.
Oh, yeah, we had to check if it's not -1, because if the value never appears, then we can't assume that if statement, right?
Okay, and for each of these cases, we want to see if only one of them occurs. No, wait. No, sorry. Okay,
So just if it's
yeah.
consistent and A0 doesn't equal -1, then it's possible.
Sorry, could you repeat that? I think wait. Sorry, let me
Yeah.
think. I think there's another way to do this. I feel like I'm overcomplicating this in the implementation part. Okay. Yeah, I think I hope this is what you meant when you said yeah.
I was thinking if A0 doesn't equal -1 and it's consistent with 0, then we can apply the if statement to 0.
Yeah. Or
I
if
think,
if A1 is not -1 and it's also consistent,
yes.
or if they're both the same. Right.
Yeah, if they were the same, then if they were the same, they can just apply 2 if statements, I guess.
Then actually we can just write one else if statement, else statement, and then return whatever the output of A0 and A1 are. So because I hope that makes sense. So if all of the outputs for zeros and ones are the same. So for example, in this example, if all of them are equal to 0, right? In which case A0 will be equal to A1. Then we can apply one else statement and say that return 0. Or if they're all 1, we can just return 1 right here. So that's my logic for it. Yeah, so and right here we can just write okay, or do yeah, okay, all caps. Yeah, and then we use a go-to statement. I mean, it's not. I mean, that's the easiest way I can think of. It's like it's not recommended, but go to works. It's fine. So go to done, like skip this entire test case because we've already found that it's okay. Yeah, so otherwise, let's see whether we can apply an if statement and apply an if statement that checks whether the current bit is 0. So if all of the zeros return 0 in this case,
Wait.
for example, yeah.
I don't think we can just print okay, because we haven't eliminated all the columns. We haven't eliminated all the rows. So you can't just print okay. Because this is only for like the rows which have that column taken. Right?
Well, we can eliminate if we just if we write one else statement, like in the problem statement. Oh yeah.
Oh yeah. Yeah.
Okay.
Yeah. My bad.
It's fine. All right, then, like I was saying, if all the zeros maps to 0, then we can apply an if statement to, if statement and remove all the 0 columns. But otherwise, if all of the ones map to a 1, then we can apply like an if statement and then remove all the ones. Otherwise, this column cannot be taken, and we continue to the next column in our loop right here. That's a lot of nested for loops. I feel like either I'm probably overcomplicating it, plus this might be a little bit difficult for bronze. So yeah, anyways. So if all the zeros maps to the same thing, then column taken, first of all, is true, right? Because we've already applied an if statement to this column. And then we go through all of the rows.
Wait, do we? Yeah.
Yeah.
Wait.
I'm just gonna put it on this row. Yeah. And we can go to the and we just break this loop right here.
Yes.
Because we've already. I mean, technically, we don't have to. If we apply an if statement to several columns on one iteration, that doesn't really matter, right? So I guess we don't have to include it. Yeah, and after all m iterations, if we still haven't printed okay, and then we print its whole line. Yeah, so I think that's the entire program. I don't know if it. Yeah, let's just try it.
Yeah, you should. I think. Yeah, I think this will work. Let's see.
Okay.
Okay, for the first test case, what do we? Oh,
okay. So
better check if auto rows are removed as well, because we gotta check if auto rows are removed at the end, because we can do it like not all together. If we have like.
No, it's I don't think it's because of all the rows are not. It's not wait.
Because if row removed I is true for all I, then it's also okay.
Yeah, but I think we will print. Okay, wait, no, I think I know the issue for this. Give me a second.
Well, yeah.
Okay, that works.
Yeah.
Basically, because technically we can have actually m+1 else statements, and the last, and yeah, technically we can, because we can have an else at the very end, and this basically takes care of that. It's hard to explain. Because at the second last step, so for example, at this step, right before we do the else, we will have only two possible. No, sorry. All of the zeros will map to 0, or all the zeros will map to the same thing, and all the ones will map to the same thing. And that basically takes care of the last two statements here. It's just, yeah, it's quite, or at the very end, after right here, we can check whether all of the unremoved rows have the same output. That works too. That works too, and probably is more intuitive. But I mean, yeah, it's just sort of to write this. Let me just submit.
Should be the same thing.
Oh. Okay. Okay.
I know.
Is there a corner case, or did we do something wrong?
I think we did something. I think we forgot to check something. Wait,
Okay.
let me just read this. Oh. If we let
I
me
mean,
think for a
technically, we
second.
also, sorry, give me a second. We can also remove this and just put if, two ifs.
Let me just make sure that like I didn't miss anything in a problem statement.
Okay, I'll look at the code.
Okay. I'm just curious. I'm gonna check for all row removes. I think consistent should always say that way. If all rows are removed, they would just continue here. So consistent should always be, yeah, it's useless.
Sure, you can check that.
What if okay. I'm just gonna like check if all rows are removed, even though like I'm pretty sure it doesn't matter. But I'm just gonna check just in case.
Yeah.
Yeah, I'll submit so you don't have to re-download. So, I think. Oh my god. It is. That's good.
Wait,
This should.
did you run
No. I think
it? It likely will give an
I have
error
an
because you
error.
declared.
Yeah, I'm re-declaring this.
Yep.
Is that one?
Oh, I'll declare like as a global variable,
Okay.
so that it's easy to find.
Okay. Let me download.
Usually in the contest, I would just submit whenever I
Yeah.
change the code, but it seems like it probably won't do anything.
Yeah, I don't think I'll do anything. I'm just being very careful. Let's see.
Tempted to write my own test case, but I'll work on it. I'll look at this. I'll stare at the code for a few more minutes.
Okay, yeah, that didn't change anything. Consistent should check it anyway. So, do we is there I'm gonna read the problem again.
Okay, so n equals 2 for the second, third test cases. Let's just do.
I'll say maybe lying. This isn't. Okay, I'm not saying anything with the problem statement, which is weird. So, think we just had to do some debugging.
Perhaps we, yeah,
Yes.
zero, for example. I don't know.
Yeah, this works. If it's 1, will it work? That also works. But yeah, because you could just compare this column. Okay, that's a problem. Well,
Wait, no.
Is that a problem?
No. So, for example, if B0 is 0, return 1. Otherwise, return 1.
Oh yeah, yeah. We
So
just
basically, you can have an else statement within an
Uh-huh.
if statement, like
Yeah.
if that makes sense.
This is so annoying. You could.
Is this right? Seems like
Let me see. If
okay, for example, if B0 is equal to
mhm,
can't do anything.
if
If B1 is equal to
wait,
that's a
I don't, I
problem.
don't, I don't think this works, right?
I think
Because
I think we just found the bug. I mean
mhm,
a wrong test case.
yeah. So let's I was gonna say let's print the column.
I would write C
This is
log.
is there a difference between C log?
You can see it at stder.
Oh, okay. 0, 1. So 0, it says both of these are 1, but it's not consistent, right? Or because it thinks like this one and this one here. So
Which
it's
ones?
okay.
Can you highlight,
It's
please?
looking at the first and third ones, which yeah, because it thinks like the outputs are the same. So I don't
Wait, I'm still a little
A0
confused.
equals A1. This I don't think this thing is, can we say
Wait,
that? Or
where's the
I mean
error?
like it's saying that like because this first one equals 1 and this first one also equals 1, then that's okay. But that's not right because it's
But
looking at
then
the
one
first
is
one
not
of the first.
consistent.
It's like looking at
Oh, okay. So I guess this is the problem. Yeah.
yeah. Let's see. Yeah, try deleting that. We'll see if that fixes it. Uh, Okay, wait, so what's the oh, is it okay because of this?
Sorry,
Yeah, wait, let me move this as well. And that should be lie.
and then just print
Yes. Yeah. Okay, wait, let's try the samples again.
I'll copy. Oh, whoops.
Oh, already did it. Oh,
Okay,
now it's saying
sure.
everything's a lie.
Great.
Well, at least you found a failing test case like that. Okay, let's go back to this. Hmm. What if we do this?
Let me try the first sample case. Let me debug why it's wrong.
Yeah.
It's saying lie.
Wait. I accidentally commented this one out. Yeah. I'll be uncommented. Wait. I'm going to 1 sec. Wait, let me okay, why can't I copy this? I just need to wait, how do I oh yeah. Okay. But hmm. Wait a sec. Let's see if this one's correctly. Okay, well, I fixed it for the first 5, but now it's saying wrong answer on everything else. Because
Wait, which I'm not sure which version of the code you copied.
I
It's pasted
like
below.
yeah, I just pasted it below. I just like removed that thing and just checked where we moved, and that fixes the first 5. But now 6, 7, 8, 9, 10, 11, 12 are now wrong. So I think we need some combination of them both. Column begin J.
Mm,
Oh my God.
Hmm.
This is I'm trying to think of a county case for that one.
Let me try this. Let me try this.
Okay. Oh, wait, this thing should be, wait, hold on. I mixed up N and M from the problem statement.
Oh,
Does that work? Hopefully. Oh yeah,
okay.
see, same thing. Hmm. Interesting. If oh my gosh. Okay. If A0 equals -1 and consistent 1. So this is if A0 never occurs and then 1's all consistent. Okay. This is guaranteed to work, I think. I think we can clear this out. For this one, if A0 doesn't go -1 and consistent 0, then J is done, and then everything as long as it is. Wait, this might be we might have to change this to A0 here because this is if it's consistent with A0.
Okay, so give me a sec.
Let me copy paste it to like my own file so I don't mess with this. I think I'm A Bij equals J, what's J? And then I here, so. Out I. Then it means so. Oh wait, no, wait. Equals and out. I know it's gonna be. Do you see anything?
No.
Me either. If 0 V I J.
Wait a second. Should we be writing line 34?
134. That's
Because
oh
we
no.
don't. We haven't
It's only if we claim it here.
Oh my
So
god.
yeah, we moved that. Oh my god.
Oh, these little bugs.
If that works, that'd be very. You're submitting, right? Okay.
If it works, it's my fault. It's my fault.
Oh my gosh. That would be like the worst way too. Oh my god.
These are the second
It's not-
worst bugs. The worst types of bugs are when you write N instead of M and vice versa.
Yeah. Oh my gosh. Okay. Well, at least that's over.
Yeah, yeah. Okay. Yeah, didn't expect you to debug
Yeah.
for that long, but yeah. If any viewers have any questions, I'm willing to answer them.
Yes. And if we want to go back to the problem two proof, if any of you are interested in that, can also circle back. I think problem three's implementation is like very easy to mess up on. Like there's a lot of small casework here and there.
Yeah, and especially because the implementation is quite long, it's easy to
Yeah.
mess up. And also, since I can't focus effectively for many hours at a time. Usually I would take a break during the contest since it's 4 hours, like 5 minutes to 10 minutes.
Yeah, yeah.
But I think because I didn't take a break, that might have hindered my ability, like mind fog.
Yes, yes.
Yeah, yeah. I guess yeah, these problems are pretty nice. Just number 3 is I would have made it like less implementation heavy, or it's probably it's likely that there's like a easier way to do this problem.
Yes, yeah.
Yeah.
Do you think the difficulty
Okay.
of problems 1 and 2 or the overall contest is similar to like last year, or like what do you think of the difficulty overall?
Wait,
Overall,
I
yeah,
forgot
it's
about
pretty.
last year. What was last year's like? One sec. Oh, I think it's a step up.
Whoops, not the solution. Let me 750 or higher. Okay, so if you got the first, let me just see if you get the 5. Sorry, let me just get a calculator.
Okay. If you get the first two and then the subtask on 3, that's like 2 out of 11 times GDP. Oh, even if you gotta get subtasks 2 to 5 in order to pass if you AK 1 and 2.
Yeah, so that's actually, I would say that's reasonable.
It's not that bad, I think.
Yeah.
Because I think problem 1 is a pretty easy problem compared to like last year.
Yeah, and I would say problem 2, I wouldn't be surprised if it's more like a guessing problem than,
Yeah,
it's hard to, you could take the time to prove everything, but I feel like it's easy to get like a strong intuition without the proof. And yeah, I wouldn't be surprised if, at least some people passed without the full proof. The last problem, yeah, this year's contest has problems are in increasing level of difficulty. So yeah, that's pretty cool. Yeah, I guess we don't have that much time to do the Java version, but it's pretty similar, since the two languages are pretty similar.
Okay. Are there any questions from the chat, or otherwise we can just wrap up?
I think we're good. So overall, I think that went really well, except for the little bug at the end, but that's very normal. I think we'll upload this to YouTube and we can end the stream now. So bye.